In the last video, we started work on our bubble sort algorithm. We're now going to continue on to selection sort. I think that selection sort is a little bit easier to understand conceptually, but the code we have to write to implement it might be just a tad bit more challenging. With that in mind, let's take a look at a diagram to help us understand how it's supposed to work. I like to refer to selection sort as the prove me wrong sorting algorithm. And I know that sounds weird, but you'll see why in just a second. So we've got the pseudocode on the right, we've got some temporary variables on the left, and then here's the array that we're trying to sort. So let's run through this thing step by step. We're again going to iterate through every element in the array, starting off at I equals 0. So let's assume up here, I starts off as 0. Then at the next step, this is where things start to get interesting. We are going to assume that the element at index I, so that would be 10 to start, is the lowest value in the array. So we're going to assign I to the variable index of min. So here's this index of min temporary variable right here. We're going to assign 0 to it. So the keyword here is assume. And so this is where, how I just said a minute ago, I like to call it the prove me wrong algorithm. Step 1 right here is to assume that the current element at I is the lowest in the array and prove me wrong. Show me if there is some other value in the array with a lower value. So that is the purpose of this inner for loop right here. Prove me wrong. Show me if there is another element in the array with a lower value. So we're going to iterate from I plus 1 to the end of the array. So essentially these 4 elements right here. And for every one of those elements, we're going to check to see if it has a value less than the index at the current element, than the current element that we are looking at, which is 10 over here. So we're going to start off at 0, and we're going to say, is this value right here less than the one that we're currently looking at I? And the answer is yes. So we're going to update the value of index of min to now be 1. The 1 right here says the value at index of 1 has a value less than the current element that we are iterating over I. We will then move on to the next element. 97 is not less than 10, so we don't do anything. And then we move on to the next one, and we see negative 30. Negative 30 is even less than the previous minimum value that we had found, so we're now going to update index of min to be 0, 1, 2, 3. So now index of min will be 3 to say that the element at index 3 is less than the one at I equals 0. We then finish up that loop. We say, nope, 5 doesn't really matter here. And then at the very last step here, we say if the index of the current element, so that's at 0 right here, it's our value 10, and the index of the lowest element, that's the one that index of min right here is pointing at, is not the same, then swap them. And so essentially what this line right here is saying is if I and index of min are not the same value, then swap these two indices, or swap the elements at these two indices. And so we would swap 30 and negative 10, like so. That stops the first iteration through our entire array, and then we move on to I equals 1. So let's do one more loop here. So now with I equals 1, we've moved on to 0. Index of min is going to be reset to I, which is 1, because remember we are assuming that the element at I is the least in the array. And then again we say, prove me wrong. So this is our for loop to attempt to prove ourselves wrong. At this time, j is now going to be at I plus 1. So in this case, it'll start off at 2, and we're going to iterate all the way to the end of the array. So we're going to start off at 97, and we're going to say, is this less than 0? No. Is 10 less than 0? No. Is 5 less than 0? No. And so then we get back down to our if statement, and we say, is I a different value than index of min? No, they're the same in this case, so no swap is required, and we then move on to the next element. So we repeat that process over and over and over again. So the next time through, we would swap 97 and 5. Then the next step, we would look at 10 and 97. There's no swap to be done. And then we would move on to 97, and there's no more work. And so we end up with a sorted array. So that's pretty much it. That is selection sort. Again, I like to call it the prove me wrong algorithm because the entire purpose of this inner for loop is to somehow invalidate our assumption right here. It's to tell us, no, you couldn't assume that. That was not a good assumption. You have to swap the two elements. So that's how I like to remember it. Okay, let's take a break right here. I want you to give a shot at implementing this thing using this type of pseudocode right here. Let's continue in the next section where we're going to put together a solution to this together. So I'll see you in just a minute.